So I'm back. I thought I was done, but then at the end of doing all those videos, I thought maybe I would show you how to do the standard deviation by hand in case you're sitting at home and you really want to get through that packet and you don't have your graphing calculator, or in case you really understand where does standard deviation come from. So this topic is optional because you will have your graphing calculator on the test, and a calculation for this is not required, but it may help you understand standard deviation better. So to calculate the standard deviation, you use a rather lengthy formula. So first let's look at population standard deviation. It's given by this formula here. So sigma x means that it's population standard deviation. We look at this, this is 1 over n, and we've got a big square root we have to deal with. But order of operations say we're going to start inside the parentheses and work our way out. So inside parentheses we see xi minus x bar, which means first we need to figure out what is the mean of our population. Then we need to take, this stands for individual points, if you remember from the summation unit. You take individual points, subtract the mean from it. After you find each individual point, subtract the mean, each difference will be squared. Then you're going to sum up those squared differences. Then you are going to multiply this sum by 1 over your sample size, or your number of databases in your population in this case, because we're dealing with population. And then finally you will take the square root, and that will give you the standard deviation. Now if you remember, before you take the square root, this would be sigma squared. That would be variance, and that is actually step 5. So you actually calculate the variance first before you take the square root to get the standard deviation when you do your calculations by hand. So let's look at this example. We have some numbers, 66, 81, 95, 97, 86, 58, 76, 73, 88, and 80. And let's assume that these are all of your available data. Maybe it is the scores on a test where the class is only 10 students large, and you want to figure out what is the standard deviation on this test. So first you would calculate the mean, and that's just you add them all up and divide by the number of numbers. So I did that already, and we get a sum of 800 divided by 10, which is 80. Then we subtract the mean from each data point, and then we square the difference for each one. So over here you see that I subtracted 66 minus 80, I got negative 14. I square it and I get a positive 196. 81 minus 80, I get 1. 1 squared is 1, and so on. You notice all of these values are going to be positive. Right here, we had a negatives and positives, and if we sum all of this up, we should get 0. Okay, this column right here of differences should equal to 0. But when we sum them, we get a much different picture of the spread of the data. So this is the square of how far you are from the mean. So this was 66 minus 80, so you're 14 units away from the mean. When we square it, it becomes 196. So this squaring, to find the actual spread, we're obviously going to, this is the reason we take a square root later. There's a little bit more work to be done. Then we add them all up. So we add them all up, and our square differences turn out to be 1360. So when you add all of these up, we now have the sum of the spreads, the squares of the spreads. So we're getting an idea of how far it's spread on either side of the mean, and this is going to always be a positive number. We then multiply by 1 over n, which is actually the same as dividing by the sample or the population size, and that gives us an idea of how large the spread is. So we're actually squaring some values, making them all positive, and then we are going to divide. So we're going to take the average of these squared values, and then we take a square root. So the average of the squared values is going to give us the variance, and then the square root of that is going to give us the standard deviation. Oh, I forgot a parenthesis. One goes right there. I know it's supposed to go there. Sorry if it drives you nuts. The difference between this and a sample standard deviation, they're very, very similar. There's just one little difference, and it's what you are multiplying the sum by. This sum is actually going to be multiplied by 1 over n minus 1. And the reason is that there is more variability in a sample than there is an entire population. So sample standard deviation is very similar. The only thing that changes is in this fifth step. It's the multiply the sum by the number of data pieces minus 1, and this is by 1 over. On both cases, I forgot the 1 over part. So it's actually, we're dividing the sum by this. So maybe I should change that. This actually should be divide, and up above it should also be divide. So suppose instead of being all the available data, it was only a sample of 10 pieces of data out of a much larger population. That means our variability of our actual population could be much larger. Our standard deviation could be much larger in the real population than it is in our sample. So we complete the same process. We add up the square differences, but this time we multiply by 1 over 9. We get 151.111. This is larger, meaning that there is a larger variability between a sample and a population. A population, we know all the data. In a sample, we don't know what else is going on, so we have to leave ourselves more wiggle room. So when we take the square root, we get 12.29. This isn't that dramatically different than the 11 that we got in the last question, but it is different enough so that you will see that there is some difference. Now you could do this in a nice chart if you wanted to. I find that this is the easiest way to do it, is to just go down and calculate the mean, subtract the mean, square the differences, add them up, multiply, and square root. This formula is not given to you on the formula sheet, I do not believe. So you are going to need to know how to calculate it by hand if you would like to do it on your own. If you are taking AP Statistics, when we do AP Statistics, we will be given these formulas on our formula sheet, and we will use them whenever we want. So just to preview, these are formulas that actually do come from AP Statistics, and you may be more interested in studying data of this way. So this really is my last video, and this is just to show you how to do it by hand in case you are antsy and you want to do all the questions, or because you really wanted to understand more. I hope you enjoyed this last video.